Can we dim the lights again and put up my presentation? Okay, thank you very much. So this will be a talk that follows up on the wonderful talk Steve Chu gave, and also what Carlo Rubbia showed us, and of course on the sustainability issue, the general one, which Bill Clark just portrayed. So let me go ahead and see. Okay, here we go. So you see, when I gave talks here before, you mentioned in general the writing on the wall, natural disasters, to illustrate that the climate is changing, global warming is happening. The problem is today to pick the illustration because the entire world is turning red, more or less. So you could pick anything. So I could refer to the wildfires in California, raging this week, for example. But what I picked a few weeks ago was change in extreme rain events. And so if I go, so it's working like this, okay. So this is, you cannot see it well, but this is more or less the temperature curve on this planet. And this is extreme precipitation events. You see, this is clearly in line, and I will illustrate it now with just a few events. So this is Houston. You see, that was the Harvey, tropical storm Harvey, and by the way, the pink color stands for more than actually 40 or 50 inches of rain, which is even more than a meter in metric terms. So you could go to the next one and think of the pink color, actually. So this was Hurricane Florence, not long ago, actually. And this is what happened in Italy just 10 days ago, I guess. So this, you can see, you can find the pink color again, so 50 inches of rain within a few days, actually. So it's happening all over the place, really. And this is maybe the most disturbing paper I have come across over the last years, actually. It was published, and Jane Lubchenco knows about it, clearly. It was published in Nature 10 days ago. It is about the re-quantification of the heat taken up by the oceans since the 1970s, more or less, 1990s here. And it's actually coming up with a new measurement, a new method to detect the heat content due to anthropogenic interference with the climate system. And actually, they claim that you have to increase, actually, the estimation by about 50%. That means the climate sensitivity may be on the higher end of the range which we estimated so far. So we will hear about this paper in the future, I'm absolutely sure. Now this is a cartoon just portraying and actually illustrating what happens. You know, the IPCC, the World Climate Council, is sounding an alarm, but you see the planet is reacting like this. You see many alarms destroyed, one by one, and it's the 6th alarm or the 12th, whatever. So the latest alarm was this one, global warming of 1.5 degrees. That was a special report where, of course, IPCC came up with the result that half a degree difference makes a lot of difference, actually, regarding the impacts, but also we can still hold the 1.5 degree line. And whether this is possible, I will discuss in the next few minutes. So this was a paper we published in Nature Climate Change, which is about the so-called tipping elements, you know, the Greenland ice sheet, the Amazon rainforest, even parts of East Antarctica. And you see the horizontal gray bar, that is 1.5 to 2 degrees, that is the Paris Agreement. And we simply ask, where would certain parts, vital organs of the Earth system, being tipped into a new state if we heat up the planet? So you see on the left-hand side in the black box, there's an entire group of things, major accidents in the Earth system that could happen already if we keep the Paris line 1.5 to 2 degrees, actually. In particular, we will lose all the tropical coral reefs, even above 1.5 degrees, and probably Greenland will melt down. Steve Chu was alluding to that. But this is not the full story. Unfortunately, it goes on like this. For the first time in a paper recently published in the Proceeding of the National Academy, and Bill Clark happened to be the editor of that paper. He gave us a very rough ride, by the way. Thank you very much, Bill, for that. And we, for the first time, looked at the interactions of the various things. What means, if Greenland melts down, a lot of fresh water goes into the polar ocean. That will directly impact the so-called Gulf Stream system. That will have an impact on the biological production in the Southern Ocean and so on. And then when we calculated all that, we found that actually we may not be able to safely park the Earth system at the Paris corridor, that means within the Paris corridor between 1.5 and 2 degrees, because what might happen is actually that the system may just slide away down a slippery slope. So you push it to 2 degrees warming, and then it will spin out of our control and go into a new state. That is the question. So this was the paper published in PNAS. It is not probably the best of all papers I was involved in. That was a paper on quantum theory, I guess. But it's probably the most important one. It was downloaded from the website 400,000 times immediately, so it will have a huge impact. And the question is now, if we push the Earth above the current level, another 1 degree or something, where will it go? And there are virtually 2 options here, and I'll show you the 2 options. The first one is the so-called Pliocene. Steve Chu was alluding, I think, and also Carlo, alluding to the sort of warm interglacial 120 years ago, 120,000 years ago, where the Earth was 1.5 degrees warmer. But actually we should have to go back 3.5 million years. That was the Pliocene. That is the best possible outcome we can think of. At that time, you have to look very closely, 400 to 450 ppm. That is parts per million CO2 in the atmosphere. And you see the Earth was warmer by 2 to 3 degrees at that time, and sea level was 10 to 22 meters higher. But what if the system would spin into the following state, the so-called Miocene? Of course, the continents were different at that time and so on. But if you look there, 15 to 70 million years ago, CO2 concentration in the atmosphere was 300 to 500 ppm, so about the concentration we are heading for. Currently, we are at 410 ppm, and we are moving fastly and rapidly into the 500 range. Temperature was 5 degrees warmer, and sea level 10 to 60 meters higher. That is the bad alternative, while the good alternative is actually this one, the Pliocene, with 2 to 3 degrees warming and up to 22 meters sea level rise. Now, if you think this is all just, this is all just science fiction and so on, this is a paper we did in Nature a few years ago. It was about reconstructing all the ice ages over the last 800,000 years. And I just leave with you, an ice age happens when the blue line, the actual CO2 in the atmosphere, is crossing from the left the black line, that is the critical CO2 level according to orbital parameters and so on. We can precisely reconstruct the last 10, if you count down from the left, it's 1, 2, 3, 10. The inception of the last 10 ice ages can be precisely described with the above level exponential function. So we can look into the future, what will happen. And actually what will happen is, remember when the blue line is crossing the black line, then there will be another ice age. That would happen in 50,000 years from now. But because we have so much CO2 already in the air, rather the orange or the red or the brown line applies, there will be no crossing anymore. So that means we have already suppressed the ice ages on this planet. And the next consequence could be that we would push for the Miocene. That means we would parachute the planet back 15 to 17 million years ago. What can we do about it? Now this is a very interesting slide. Now on the left-hand side you see this thermometer. Green means below 1.5 degrees, yellow is between 1.5 and 2, and then you go up to 4 degrees, 5 degrees. And you see on the world map now the countries which are currently in line with the various colors. So if you look to the US and Russia, they are on course with their current climate policies for a 5 degrees warmer world. The only country in the world which is in line with the Paris Agreement regarding 1.5 degrees is Morocco. Surprise. It's not Germany, it's not Sweden, it's Morocco. So that leaves me, and that is my last slide in order to save for the debate, Schellnhuber's law. This is of course tongue-in-cheek, but it's according to my personal experience. You know, in 1988, I was a young Heisenberg professor, and I was at the University of California, Santa Cruz, beautiful campus, doing complex systems science. And in that spring of the year 1988, there was this famous Senate hearing where Jim Henson sort of testified and said, what you experienced, it was a very warm spring. What you experience now is already global warming and it's man-made. Now, of course, he couldn't prove it at that time. He was right, but he wasn't able to justify it. But at that time, everybody was talking about global warming. That was the interesting thing. Why? Because it was a distant threat, and people, even the media, picked up on it. So what you see is, my law is that the sum of attention and threat is a constant. That means at that time the threat was very small and distant and got a lot of attention. Today, 30 years later, the threat is imminent, absolutely, but we don't care anymore. The attention is being reduced. It can be reduced to 0. But believe me, we cannot afford that. Thank you very much.